I request all the people to mute their mic, right? Mute their mic. Okay, now please look into that. We are into the second week of this semester, right? So already we have spent around 3 classes on laboratory, 2 classes on introduction of this particular course, right? I have asked you people to go through the programming, right? First one is about command line argument. The second one is displaying the process ID of parent as well as okay self. Then third one is about creating the child process using the fork, right? I hope that you all people have done. Do you have any difficulties in these three okay programming exercises? Hima Rashmi, you can look into the chat room and let me know. If you have anything, you have to put it in a chat room and let me know. Hima Rashmi, unmute. Hima Rashmi.
Yes, sir.
No.
Sir, no one has put anything in the chat.
Okay. Did you do programming? Did you complete a command line argument, Hima Rashmi?
Yes, sir.
Then about the get PID, get okay, parent PID, that.
Yes, sir.
Then fork.
Yes, sir.
Okay, that's good. That's good. We hope that all others have done. Those who have a system, those who don't have a system and all, when you come back here, when offline classes will begin, right, we will give an extra slot for you in the evening. You will be getting through that. So such people need not to worry about that as such, right? So today we will begin with instead of laboratory, we'll begin with the operating system introduction, whatever that we were talking all about. See, the last class we spoke about the memory hierarchy, cache memory, main memory, secondary memory, and different parameters that we have used to compare that one. The all PPTs, okay, that whatever I'm using, I made it already available to you. You people can go through about that, right? So now let's begin, right? It is again introductory part that continues, right? We introduce about in the first chapter about the various services offered by operating system. You look into that, you can see the end user, okay, on the top, right? So you compile program, you use the editor, okay, you do a lot of other work, right? Sending email, whatever that is there. You are called end user. Then I told you that one, you for doing sending email, for compiling a program, right? For okay, writing some letter, okay, you will be using compilers, you will be using assemblers, you'll be using text editors. Sometimes you'll be using database system or some application program developed so that you can send the email and all. You use a browser. These are all applications that you'll be using. Then look at that. Then all these applications in turn they have to communicate with operating systems, right? Then operating system in turn uses a computer hardware, then provide a service to you. Computer hardware rather than computer hardware, what I can say that one resources, right? What are the resources? In order to run your program, you need a CPU, right? In computer organization, there is another parallel course we study in that. To store the memory, you need a memory, right? You need a different devices. Okay, you need a printer, right? You need a hard disk, right? You need USB connected, so many other devices, keyboard, and all other things. So these are all different okay devices, or sometimes you can call as a resources. Resource when we say it is the okay CPU processor, right? Then we have a memory, then we have a devices and all. So when we call the resources, all these resources are required for the program to run. You already experienced running a program, right? Command line arguments. I said you about the command line arguments, and there you're using two parameters there, ARGC and ARGB. Who will provide it, right? When you run a program, there is a C startup routine. The C startup routine, okay, whatever that we are speaking, that sits somewhere here, right? So the whatever the environment variables are there, whatever command line arguments, whatever you are given, it will ensure that it is made available to your program as an arguments, right? And in turn, you will be using all those things. So when you look at please buy the book, second book mentioned in the syllabus, Galvin, right, that we use for the first two chapters, and remaining all, okay, you'll be using the first textbook that is printed in a syllabus. Both the book you are purchasing it. Now, as per the textbook, when you get into that one, okay, what are the operating systems? What is an operating system? Okay, as you can see that one text given at the left hand side, it is an intermediary between the user and hardware. Fine, right? It provides an environment, okay, in which user can execute a program, okay, in a convenient and efficient manner. Convenient, I mean that one, you have got your own facilities available in every, okay, system programs or the application programs, whatever that you use. And okay, you ensure the correct operation of the system. It ensures operating system correct operations, right? If there are any failures, notifying that one, okay, all that, okay, self corrections and all these things, it makes use of that. And prevent user programs from interfering with, okay, proper, okay, operation of the system. See, when you look at a system, okay, it is not necessary that a single user is using that one. Nowadays, you find that, I mean, in your laptop, you are a single user using all the things. But in case of the servers, right, okay, where multiple users are using, okay, the system, multiple programming language. It is not that only C program. Simultaneously, C program, Python, Java, n number of, okay, users, n number of programs are running. So that, okay, one working environment should not interfere with the other working environment. My program, my input, my output, my resources should not conflict with other resources and all, right? So it will ensure all, preventing all such interference of a program or the user of one, okay, with other things and all. That's what is the responsibility of an operating system. This is an introductory course. See, in the fourth semester, when you get into that, right, you'll be studying in detail about the other aspect of an operating systems, right? Generic. But here we'll get into very soon about the specific things. All exercise, whatever you do, they are under the specific to Unix operating system. Okay, Unix system programming, basically part of that you do it now. Part of the things you will do it in the next semester. So you got introduced to command line arguments now. You got introduced to that one to know the process ID and my parent process ID. We got introduced to how child processes to be created, right, using the fork, and this is what you got it now. So other, okay, deeper things we'll see it in the next laboratory, and another set of programs will be giving it. I expect you all people, okay, completed these three primitive exercises given there, right? How to execute another program, how V fork is different from the fork and all that we will see it in the next laboratory. And I wanted you, without any hesitation, put forth all your queries so that that will be answered. Do not assume that anything and keep quiet. Fine. Now, okay, we say that uh, operating system acts like a resource manager. What are the resources? Processor, memory, devices, okay, etc. Right? So it will act like a resource manager. Fine. And just now I was talking about the multi-programming, right? Uh, Maybe uniprogramming, multi-programming, if at all you look into that. Now assume that, okay, I'm the a processor, and assume that one of you, Manoj, is as, okay, uniprogramming or a single job and only one program that is being run. So what happens is when Manoj is waiting, in fact, is not responding, right? If this is the only program, if I'm executing that, managing that one, then if a program is stuck due to some input output operation and all, then I'll be waiting unnecessary. So how do you enhance my performance? You enhance my performance by making it available multiple programs to run. Multiple programs, when I talk about that one, okay, it is multiple jobs. Multiple jobs, when I say that one, not necessarily it is in the same programming language. It could be, okay, other programming language, other application program. It could be editor, it could be compiler, okay, it could be running a program and all, or it could be some task, some job, sending email, receiving email, right? It could be printing activity. It is anything that a computer can do, everything we call as a job, right? Thus, so single user cannot keep the CPU and IO device busy. So to improve the performance of processor. Okay, multi-programming, multiple jobs are being assigned. When a processor is waiting or when a teacher is waiting for Manoj, if Manoj is not responding due to some IO operation, then I can get into Himarashmi. I'll say that one, do you have any job to run? So I'll execute this. This is okay how I can switch from one user to other user, one process to other process. Hope you understand the meaning of the process now. Program in execution we call as a process. When I say program, don't think that okay, it's my C program. It could be editor, it could be compiler, it could be browser, it could be okay some printing job, right? Internally, everything is a program. A program in the executable version, okay, that is being called as application program, business application program, your program, whatever you write it, right? So multi-programming organizes its job so that CPU always has something to execute all the time so that it can improve its performance. Right? A subset of the okay total job are kept in a system memory. So I told you in the first class, right? Memory hierarchy. When CPU wanted to execute anything, it has to be there in the main memory, right? So there are n number of jobs are running as a part of a multi-programming or the batch system when we talk. See, all these things need not be in the memory. Memory is nothing but your okay brain. Okay, anything that Himarashmi with a great difficulty I remembered your name. So now I know Himarashmi. It is there in my brain, right? There are many other students whose name is not known. It is there in my pocket, my okay attendance book, right? In order to I to call somebody from that course file from that pocket, I have to bring it to my memory. Then only I can call somebody. Are you getting it? So all the jobs are not kept in the main memory. It is brought into the main memory as and when required. Okay, then it is being executed. Right? Thus, and one job selected and run via job scheduling. When you go to doctor, okay, there is somebody, okay, clinic manager, right? Clinic manager who allow one at a time, who has come, who has high priority, who paid high, who booked early, right? Those people are allowed to get inside the doctor's room for consultation. So who is doing that? It is a clinic manager, right? And we call as a job. I mean, this patient are being scheduled, right? So job, there are a number of jobs. Some job will be admitted so that it uses CPU. Some job, right, are waiting. Okay, some job are printing and waiting, right? It can go out, again wait, again come back and make use of CPU. This job scheduling concept, okay, we will be studying in depth until next semester also. It is too early to go beyond this point now because this is the first slide of introductory class. So I have a number of jobs. All jobs, right, are not there in the memory. Some job is brought into that one. Again, it is being scheduled, brought into that. Then some out of the things which are brought into the memory, okay, one of the job is picked and being executed. That is also called being scheduled, scheduling. Who would do that? Scheduler. And if one particular job is taking more time, it will suspend that, brings another job, right? So that all multiple program, multi as a part of multi-programming batch system, okay, they all okay get the time of say 1 second or 500 milliseconds within that it works. If you're unable to complete that one, the switching takes place, and this is called time sharing. The time of the CPU is being shared by multiple programs, right? So that they feel that one, okay, the CPU is allocated only to that. You don't feel the short, okay, milliseconds of time that whatever that is available, right? This. So each user has at least one program execution memory, we call a process. If several jobs are ready to run at the same time, scheduling is being done, CPU scheduling, so that process is allocated to different, okay, the program or the process or the user, right? And if the process, okay, don't fit in the memory, it is being swapped out. Part of that is being brought it. It is not the entire program has to be there in the memory. Part of that is being put into that. Then that part execution is over. Then the next part you have to bring it. The existing one is swapped out and new part of the program is brought into. So when your program is bigger than available memory, still the program is being executed. So don't think that your entire program from the starting point till end point is made available in the main memory in one shot, everything. No, right? Maybe few instructions are brought. When that execution is over, it is swapped out, sent out. Then next instruction are being brought. This is called swapped in, so that virtually, right, you can run the program of any size bigger than available main memory. This is possible because it's called virtual memory management, right? Your program is of size, say 1 MB, memory available is say, okay, half MB, still 1 MB program can be run on half MB memory. Or assume that program is of 10 MB and memory available is 4 MB. Still you can run because piece by piece it swaps in, runs it, and then it takes. So this mechanism we call as a virtual memory. We will study that in detail in the next semester. So what is a virtual memory? The virtual memory is that memory, okay, which right runs, which facilitates, organize itself in such a that it can run the program of bigger than what is available memory, right? By swapping in, swapping out techniques and all. This is the concept of a virtual memory. So I forgot you. I'll be creating one in-class question bank where all possible questions what we discuss, I'll put it, and I'll give authority to both Himarashmi and Manoj so that you can edit all these things, right? Now look at that. What is a virtual memory? What is the use of that? What do you mean by multitasking, time sharing, multi-programming? What do you mean by batch system? What do you mean by job scheduling? What do you mean by CPU scheduling? What is an operating system? What are the the functions of an operating system? All these questions, right? You will be going through that. I'll be putting it in a that question bank through Google Class. I'll make it available to you. Now moving to right other things I said. Now initially, now you can visualize the operating, I mean entire memory. Okay, assume that 512 memory, something like this. There is some area called operating system. It has to reside permanently until you switch off the power, right? You shut down the system. The moment you started by powers giving power supply, right, the entire operating system from your ROM, EPROM, where is battery backed up, from that there is something called boot program. That boot program brings the image which is there in the hard disk, right, and loads in right in the some part of the memory which is reserved. Nobody can get into that. Then give the control to the operating system. Then you get a command prompt or whatever that is there. Operating system is ready now. Then when you compile a program, you will compile a program, I will compile, n number of people, all the jobs, they come and sit in the memory. It is dynamic in nature. How these things are being organized, you will study that one, okay, in future. I mean, in this semester partly and in the next semester partly. This is how you can visualize that your program or the jobs are being loaded into the memory. When I say here, for your more detailed information, right? When I say I'm compiling command line argument, that is a job is loaded here. But it is, don't think that entire set of instructions are being loaded. In that first three instructions are loaded and memory allocated for this is okay over now. Okay, remaining 10 more lines are there. Fine, all right. It executes first instruction, executes second instruction, execute third instruction. Then it says that one, this work is over now. Now what it does, it swaps out, sending it from the main memory to second memory. It sends it out, right? Okay, something like this. Then it brings back the remaining instruction, the instruction number 4, 5, 6 in this area, and runs it. And not necessary that it has to bring it in the same area. It can come here also, and job 4 may go here, right? So all this memory management activity, swapping in, swapping out, right? All these things is done by operating systems, right? Any question at this stage, limited to this, don't go ahead of time, because lot of days are there in the semester, and the same thing you will study in second course operating system next semester. Any question at this stage? Himarashmi, right? You can read the question from the chat box and let me know. And all these slides are made it available, but please read textbook. Don't read only slides. Any questions, Himarashmi? You can
No,
unmute.
sir, no questions
That's
yet.
good. That's good. That's good. Right. I'll go to the next one. So when you look at that, operating systems, okay, safety, security is the most important thing, protection. Right? I told you that one. Here, let me put a marking here. Mm, I can use a color, okay, different color. I can use a different color, right? Now look at that. This operating system, whatever that is there, your program running here, your program which is running here in job one should not access this particular okay part of the operating system. Or when you run a program, you are using here printf. Fine, all right. You can use. You have authorized to use it. Here printf, right? But there are certain system calls you use. Say fork, right here, right? You should have a privilege to run that one. So this operating system, right? It runs some of the system calls and your user program also. Got it? So there are certain privilege required. If you have a privilege, then only you can run system calls. Some of the system calls, what you have gone through already is right. Get PID, get PPID, right? Then fork. That's limit only to that, right? So you need okay operating system to protect itself, okay, and other system components, right? So it works in the dual mode. Two modes in which work, user mode and kernel mode. And naturally, there is something which will distinguish between which mode right now it is working, user mode or the kernel mode. Got it? So we use a bit, right? Now question is that one, what is the purpose of dual mode operations of operating system? It could be 1 mark. Question number 1 of semester end exam. So it is dual mode operation allows US to protect, sorry, operating system to protect itself from other system components. Now look into that. How do it works? Already you were working, right? You executed get PID, get PPID, okay, fork and all. So your program is here. That is called when you execute your program, it is a user process we call. A program in execution is called process, right? Then when you call system calls, right, say fork, whatever that is there, it gets into the kernel mode, right? It executes that system call here, right? Then it will change a bit and come back to this one and execute that, provided you are privileged to execute that. All system calls, right, you may not have a default privilege like this, right? We shall see that one later, what privilege, how to do it and all, maybe in the next semester, right? So every program when you run it, whenever you like, it runs in two mode, user mode and the kernel mode, and it has its own management. Are you getting this, right? So now, okay, some of the things already you people know about that. Okay, let me tell you. A process is a program in execution. You know about that. Program, when you talk, a program, whatever that you have, okay, this, okay, we call it as a passive entity, right? When you run that one, when memory is allocated, when CPU executing the instruction, right? We call it as a process, we call it as an active entity, right? Now the question is, what is the difference between the program and the process, right? That could be 1 mark question, right? And a process, when you execute, it needs the resources. Okay, what kind of resource? I told you already, operating system manages resources. See, resources in the form of a CPU, in the form of memory, in the form of input output devices, in the form of the files to store, right? And many things, right? So when you run a program, I told you it will not bring everything. Few instruction it brings, then execute that, then it takes it out, swapped out, and brings the next one. So CPU should know that one, what is the next instruction. There is something called in CPU, right, program counter, which will keep track of the next instruction to be executed. So your question may be, you will study this in detail in computer organization, right? In this semester only, right? Himarashmi, okay, you have a computer organization, Himarashmi, Himarashmi, Manoj,
Yes, sir.
computer organization classes have started.
No, sir. Today, sir.
Okay, you will be studying in length about all these things, program counter and all there. So we will see, tell you that. Okay, only thing is that it contains a address of the next instruction to be executed. What is the next instruction you are going to execute? This, that's all, right? We speak about the multi-threading later. We'll take up this later, right? This. So now, okay, we'll begin one by one, right? We told about, okay, process is a one which is to be managed by operating system. It manages the resources. One of the resources is CPU, and the program runs in CPU, and so is the process, right? Now, the thing is, the operating system is responsible in providing services like it should allow you to create a process, delete the process, right? Creating a process. So already you have gone through one example called fork. You created a child process. Himarashmi, can you acknowledge me? Right? Why did we, okay, add that small program? Okay, now because when I say that one, you can create a process. Question is that one, it should not come in your mind how to create it. You already gone through one small exercise of 2-line code. Himarashmi, am I right?
Yes, sir.
Yes, that's a good thing. That's why every assignment that whatever we give, please do it, interact with us. But there are many other ways of running other programs, right? VFork is there. Difference between fork and VFork will study. Then how to execute another program. I've written one program, A dot out or something Fibonacci, okay, executable code. Then from another thing, how can I execute that one? All that kind of things we will see it through assignments in the laboratory, right? Hope you all people appreciate creating a child process using fork. Am I right? Am I right, Himarashmi?
Yes, sir.
That's good, right? Then, okay, when I create a okay process and run it, I can suspend it, I can resume it, right? And I can synchronize between that. Again, I told you that one there should not be any conflict between the two jobs, two process running. I run my Python program, I run my Java program. They should not conflict as far the resources concerned. Or my C program with another C program, they should not conflict with each other. So how do I synchronize, okay, among the different process running and within a process? For example, within a process, when I said that in your program, in your exercise, you created a child process. Parent and child run simultaneously. If at all, the code is written such a way that the sharing information, if they okay collide with each other, conflict with each other, then there is a problem. Are you eager to know that how do they collide with each other? How do you collide with each other? Himarashmi? Himarashmi?
Yes, sir.
Yeah.
Yes.
How do they collide with each other? Okay, probably you may be eagerly waiting for that, but it's too early now. Right? Too early now. So my explanation, theoretical things, you should take it now in the first introductory class. We will slowly get into right all these things. Right? Then look into that. One process may communicate with other process. A parent can communicate with a child. How do they communicate? And parent and child, it may so happen that they get into the deadlock. Both cannot proceed because of they are dependent on each other to complete. Both will not complete. All these aspects the operating system will manage. And you will be studying all these things in a subsequent chapters of operating system in next semester, right? The operating system is split into two courses. One is introduction to Unix operating system, then other one is operating system. Put together you will complete the total learning in totality. I hope that you people appreciate this kind of things. Sometimes theoretical things you have to absorb. Sometimes, okay, practical things will give to you. As for the first point is concerned here, creating the process, you already got it. But still in depth we'll get into. In depth we'll get into in the laboratory exercise. I hope that every student have completed command line argument example, displaying parent ID, okay, and its ID, process ID, and okay, creating a child process using fork. These three exercises everyone, okay, has completed. That's what is assumption, except those who do not have a system. For them, we'll arrange once offline classes begins. Right? With this assumption I'm getting into. If this assumption is wrong, even for a single student, talk to CR, Manoj and Himarashmi. Again, I'll be calling you extra class only for those, right? In the evening and ensure that you understand it. There is no room for not understanding anything, right? So something theoretical ahead of time, we take it, but which we'll study that later. Something we do it now, right? This is how it is being scripted. In fact, course is like that. Now, as a part of the process management, what it does, you know about that. It should allow you to create process, delete process, suspend process, resume process, synchronize it, communicates right among the processes. Okay, deadlock manage it. Now the question here is that one, right? List the various okay activities operating system do as a part of process management. Got it. Similarly, list the various activities the operating system do, okay, from memory management perspective. Right? I told you in memory management already, right? It will bring in the okay the executable code. Swapping is being scheduled, right? If okay memory is not sufficient part of that it brings, then remaining part whenever it wanted during the execution, right? It existing thing it swap out, bring next part of that. Got it? I mean, okay, this part, this is the responsibility of the memory management aspect of an operating system. It execute a program. How does it execute a program? We'll see it in next laboratory. I want to execute one program. You write a dot out. You write executable command, but I want to write my own program which will run another program. How to do it? Himarashmi, I think probably you are eager to know about this. This is what will be done in the next laboratory. Himarashmi, am I right?
Yes, sir.
Oh, that's great. Sometimes you need to have a patience. Patience, wait until laboratory. All laboratory exercises are scripted to give practical exposure part of this. So executive program is a responsibility of memory management, right? All or the part of the data that is needed okay, by the program must be brought into the memory, right? Then optimize, I mean, memory management activities like keeping track of which part of the memory are currently being used by the by whom, bring that which is not required. If required things are there in the secondary storage, bring them here, swapping, swap out, okay, moving the data and the program process code in and out, swap in and swap out, and manage space during this process, right? When you go to hotel, when somebody leaves, that when you get into the cleaning work is done. Are you getting it? Okay, probably some people are used extra bed. When you get into, you don't need extra bed, it is to be removed out. Are you getting it? Allocating and deallocating memory, this is equivalent to that. Allocate memory, deallocate memory, swap in, swap out, right? Execute a program. These are all responsibilities of operating system from memory management perspective, right? So again, you will get a question, list and explain the operating system responsibility in terms of memory management. Now, file management, right? So in C programming, you go through the files and all, right? Probably some of you might have already used. Your email is there. Your program you have written that is stored in .c files. You list that one. You use a VI editor. You open it. Who will help you to do all these things? Himarashmi, which editor you are used in first year C programming?
Sir, we use putty.
No, that is to connect it. Once you connect it, there you are using editor. V editor or edit.
Yes, sir.
V editor, madam.
Yes, sir.
V editor. When V editor can open a file, it can store the file, it allows you to edit where it is stored in the hard disk. Who will do that? Operating system, finally. Are you getting it? Okay, the .c program, that is a file. Executable of a file, a.out is a file stored in the disk, right? So, file management in terms of open a file, close a file, creating and deleting a file, manipulate a file, you go and edit that one, right? Who will provide a facility? Operating system, right? Stores in a secondary storage, it does a backup, okay, if required. So this is, and who can access the file, who cannot access a file. I think this exercise also I'll show to you in the next laboratory session, right? What access control mechanism, that is what is the, okay, security. Who can okay, access that? Who cannot access it? This exercise we will take up in next laboratory through practices, right? So all this is part of operating system management. Open, close the files, store it that, read, write, right? Then access control, who can open that file, who cannot open that file. Are you getting this? Right? Then what else? Um, as a part of storage, free the space, storage allocation, disk scheduling. Okay, when it is stored in the disk, right? When you wanted to read a particular file, wherever it is, there are no read write headers to keep moving there. Now, there are different technology used in disk management and all today. Are you getting it? So we'll see that also, right? So these are the activities that operating system do, like as far as the file and storage management is concerned, right? Then protection, it provides a protection. I told you. Tomorrow we'll do this exercise. Actually, in Unix operating system. See, okay, when you write a program, your program is protected by other program. When you create your file, it is protected from other files, other users. Okay, who can open that file, who can close it, all that thing is being seen. And you know about the viruses and all. Okay, it is to protect itself from against all internal and external attacks. So there are different kinds of an attack that we'll see it later. But what is a simple thing that you can understand now is a virus. So some application program managing all the things is required, right? And I told you that when you are the user, you'll be given user ID. Like process ID, user is also given a user ID. Then they have got a privilege. I'm a user, I created my file, I can access it. But my friend Manoj cannot access the file which I created, but he can read it. He cannot execute it. I'll tell you tomorrow. I mean, in the next laboratory session on Friday. This particular assignment I'll create it and you'll be getting into this. Okay? Right. So, in general, services offered by operating system includes program execution, I/O operation, file system, communication, resource allocation, accounting, protection and security. Resource allocation includes processor, memory, file system, devices, etc. Right? And error management also it does. So list and explain the various services offered by an operating system. You can list it, all these things. And write 1 or 2 lines for that because it's the theoretical stuff. Another question is, I'll create a question bank today night. What do you mean by system calls? Write a C program to explain use of any system calls. Himarashmi, are you understanding the question bank? How do we build? I am going to build that
Yes,
one
sir.
and give it to you by today night. right?
Yes,
That
sir.
will facilitate you to reading. Don't think that you get a question from that bank, right? I wanted
Yes, sir.
Manoj and Himarashmi send your email to my WhatsApp once again, so that today after creating this, I give a privilege to you, so that after every class you can edit that one and write all possible question whatever I dictate. Okay,
Okay, sir.
Okay, sir.
that's good, Manoj. That's good, right? Himarashmi. So what is time now? Right.
Introduction.
Right. 3:11. So any questions here? We'll stop here. Right. I would like to take questions from you. Any questions? User can put it in the chat box now. User can put it in the chat box now. Let me summarize what all the things that we have done today. We went into what is an operating system, right? It is a resource manager managing resources like processor, memory, device, etc. Then we went to multi-programming, batch system, turn, okay, IO scheduling, response time, CPU scheduling, swapping in, swapping out, virtual memory, time sharing, multitasking, all these things, term you should know. How the layout of a program's job looks in memory, right, does. Then user mode, kernel mode, dual mode, why dual mode is required, that part. Other part will see it, right? This is how the things execute in user mode and kernel mode. Then program and process, program counter, then the functions of process operating system as a process manager, functions of our operating system, right, as a memory manager, right? Session will close in next 5 minutes. We will terminate this. Then functions of an operating system or responsibilities, okay, from storage and file management perspective, right? Then why protection security is required, right? And we told you that we'll demonstrate this protection, right, okay, tomorrow, thus as an activity in the laboratory, I'm sorry, right? And we said that when these are the different services offered by operating system, right? With this, these are all things we have studied. With this, we come to the end of today's session. Please wait, all of you. Do you have any questions? I'll stop sharing my screen. Wait, all of you. As many as 51 students have attended this. 51. So remaining people, right, please get into, right, you must attend sessions, right? Any questions, Himarashmi or Manoj at this point? If not, we will close this class.
No, no questions, sir.
Okay, thank you. Even if they have a questions in, they can ask in the next meeting. So we will get into next theory class, then Friday all laboratory sessions, right? Okay, and I assume that first three exercises you have done it. Command line arguments, process ID display, parent ID and process ID, then fork and appropriate lab exercises. And you have uploaded that. Those who have a system. Those who don't have a system will ensure that when they come back here, they do it. But that will be quick at that point of time. Thank you, one and all. Right, I'll stop now.